All right, well, on with the day. So we're gonna just do a quick touch back on yesterday. You know, we talked about what a supervisor or a head end is, its basic functions. Like I said, modern systems really have shot for the moon with the functions that they can provide through the head end, especially when you get into the big corporate offerings by companies like Trane, Siemens, Johnson. They really have added a lot of bells and whistles type functionality. Not that it always gets used, but at a basic level, your supervisor needs the ability to do things like alarms, histories, user interfaces, things like that. Has to help facilitate communication between your controllers if they don't have a built-in way to do that, which in some systems they do, some systems they don't. Okay. We talked about some networking. We kind of skimmed across the top of that topic at about 90 miles an hour, good hydroplaning speed. But does anybody have any questions on that one? Anything that came up through your brains overnight, something that popped up? Hey, what about? It's all right. We'll run into more questions. We talked about BACnet. Got that nice presentation from Andy. Talked about some additional, issues with BACnet that aren't, the greatest, but it is what it is. Everything has flaws, right? Everybody makes mistakes, so we move on. We figure out how to fix the mistakes and grow from it. And I need to offer a correction. Thank you, Connie, for asking this question. I had to look up an answer for Connie last night because she came to me and asked, or stated that she thought that BACnet only uses UDP, so it only does broadcast traffic. And that's correct. I had said that it uses UDP and TCP. So I stand corrected. The interesting thing about this is a great question, because how often do your students bring you a question that you go, let me get back to you.
Every week.
Exactly, right? You got good students, Ted. I like it. So, on a question like that, where are you going to go to find the answer? Google. That's what I did. I Googled the question. Does BACnet use UDP or TCP? Guess where it threw me? BACnet.org. Okay, so I already knew, hey, wait a minute, that's a verified useful source, and it referenced back to BACnet Standard Annex J, which is when they first added IP support to the BACnet standard. So, found the answer to the question. It's kind of an interesting read. I can send the article out if you'd like, but when you run across questions like that, hey, that's opportunity for us to learn. So thank you, Connie, for asking that question and correcting me. Or making that statement and challenging me. There we go. That's the better way to phrase that. So, anybody think of any questions related to BACnet or anything else we covered yesterday?
I have a question.
Fire away, Justin.
The setup that I had, could you walk through that of what I read? I understand when we have to put the kind of a router on the disk and jump on this.
Correct.
So can you kind of walk through that process?
So that is a great question. So the setup that we have, I'm not going to lie, is about ugly. But it is also a realistic setup within a building controls network if you have to run your own network. Because at each table, so for each 2 participants, we have a 5-port network switch. You could imagine that sitting in one of those in each of your control cabinets throughout a building. Okay? Then running down the middle of the room, we have an additional 5-port network switch. This would connect, coming back to a more central point on a floor maybe, and connecting to the other floors. So we run right down the middle, and yes, if you start doing the math, it works for the first row, and then the second row it goes a little bit fuzzy because now we have 4 that has to come to 1 that has to talk both ways. So I think it's Rob, and Robin's table actually cuts straight back to the next row. And then the back row amplifies that problem again. So we end up with 1 line running from the first row of tables to the second line of tables, 2 lines from the second line to the third, and 3 lines from the third to the back. Okay? The back, of course, is where I've got all my controllers set up, and there are 3 network switches sitting back there, all full from the connections that we have. One of those connections at that back is a cheap wireless router. Okay? Literally, I think this was a $30 D-Link router that I bought, I don't know, 7 years ago, 8 years ago. Never really had a use for it, so it sat in a box for a while, and now it's one of my backups for my classroom. Okay? But that is what is now providing access for Justin and Mario and Peter, to connect into our network. So from that standpoint, did that kind of help, Justin, or did I just make a mess of it? Okay. So, and the reason for that is because I knew coming in here that some people weren't going to be able to provide or bring a computer with them that administration was totally happy with. Just how it goes, right? So having that backup situation, being able to adapt to your students, is really important. With Justin and Mario, they did not have the administrative rights to be able to set their IP addresses. Peter's computer didn't have a hardwired port so that he couldn't plug Ethernet in. I've got a couple of USB ones that work great on Windows. Well, now I know they don't work on Mac. So, again, one of those solutions to pivot. So we started off using an individual small router to connect to their controllers for the initial configuration. Once those controllers got connected to the network, then we have a more permanent station for multiple people to connect to. So, one of those just trying to be prepared for what can go wrong. Robin.
So I'm puzzled by this how backup uses UDP between networks. Does BBMD actually use TCP/IP, TCP to communicate to another TCP? Because otherwise they couldn't get out of there. UDP won't get out of the network.
I believe that is correct. Yes,
So that's
that they
the one
use.
exception is the BBMD. It also explains
But-
why BACnet is not a terribly efficient networking protocol because
Correct.
it uses UDP.
Correct. There is also another way that it can get around the routing between networks, and that's a multicasting through UDP. But that's really a great way to piss off your network admins most of the time. So BBMD has become much more of the standard way to do it.
And if I thought that I could get an answer, I would ask why doesn't BACnet use TCP, but I don't think that that's probably something that we can answer here.
It is not something I can answer. Why they don't use TCP once they establish their initial connections, well, I can partially answer that. BACnet is a standard. It's one of those standards just like you'd expect out of ASHRAE. It started over here on this corner, and then it grew and expanded. So some of where it started influences its legacy moving forward. And BACnet was originally designed as an MSTP protocol, a 2-wire communication. Then it grew into an Ethernet protocol, okay? So the literal networking hardware level, okay? It did not need UDP or TCP to run. It was actually just using the physical addresses. It didn't use IP addresses at all, okay? Then, as networking expanded and grew, they added in the IP support. So a lot of how they do things on IP is significantly influenced by how they did things in Ethernet to adapt to the IP.
Right, and the other networks don't have point-to-point, they're all broadcast, right? MSTP assisted broadcast.
Yes. Yeah.
So there would be, standardized, okay, that makes sense.
Yeah.
That does make sense.
So.
That's scary that it makes sense.
And one of the things that will be really interesting is as they develop more on the secure side of BACnet, how, if they're going to maintain that broadcast methodology, or if they're going to step forward and move more towards TCP, which is by default a much more secure form of communication. So we'll see where it goes. But that is, I actually could partially at least answer that question.
Yes, thank you.
Any other questions that came up? Great so far. Keep them coming today. All right. Well, as you know, when you come up with them, ask. So, today's plan. Today is not as heavy a day as yesterday was. So, it's not going to be quite as much fire hose, maybe more garden hose. Here, at least for the start. We're going to finish up our BACnet lab that we were working on yesterday. We still have yet to actually add devices to our controllers. We have yet to talk to any of the points on any of those devices. So we still have to do that. We are going to add alarms and trend logs to our system. We're going to discuss why they're useful, of course, some of the important questions related to setting those up as well. And then we're going to actually do it in our system. We're going to have lunch after that, where Connie and Jenny have kindly agreed to present some of their lesson plans from some of the projects that they've been working on. Afterwards, we're going to have a presentation on data centers by Paul Ehrlich. That will be another Zoom presentation. And then after that, we are going to head over to Cyrus One Data Center, which is just a little bit east and south of us, over in Council Bluffs. By the way, thank you, Bob Clark, for setting that up for us. The manager there, correct, is chief engineer, is one of Bob's former students. So.
Wow, that could be me. So we can do whatever we want.
The funny,
Internet's going down today.
one of the funniest things, though, is we really can't ask his student where the bodies are, because Bob will just tell us anyway. He's shown them to most of us. All right. Sound like a fair plan for the day? All right. After the data center is done, the shuttles will be taking you back directly from the data center back to the hotel, with the exception of Robin, who's going to ride with me back up here to grab his car.
Hopefully we get to go into the council pretty good.
Yeah.
That'd be awesome to see.
We'll find out. I know that I believe that there's a presentation that they're going to give as well while we're there. So we'll see what they've got to say about their own data center and what they're doing. All right, let's do it. Back to BACnet. So let's go ahead and jump back into our systems. Hopefully you remember what IP addresses you set. And we're just going to do to set up a discovery. Oops, I need to remove some devices. Sorry. By the way, if you add something that you want to get rid of in here, it's really easy to remove it. Right click and delete device or delete item. Don't left click first. Just right click. Okay. While you start your scans, I'm going to talk about what some of these more. I was going through that and you couldn't see. Yep, that seems about right. There we go. Now that you can see what I'm seeing, while you start your scans, let's talk about some of this information that we've got here. Because we can limit our scans, we can narrow it down. Because, you know, these scans take time. One of the things you never want to actually have happen with BACnet is you never want to do a scan like this and get results really fast. Counterintuitively, that's a really bad thing. If you get results fast, that means the scan didn't actually succeed properly. So if you're not sitting and twiddling your thumbs for 30 seconds to several minutes, something went wrong. So, and part of the reason for that is when BACnet is doing its who is statement, it takes time for it to bounce around the network and everything to come back. And when it sends out its initial statement, depending on how the algorithm for this controller is written, to Bob's question yesterday for Andy about what's your favorite discovery tool, you know, everybody has to write, you know, there's rules about how to do the discovery, but within the software, there's different ways you can accomplish it. With contemporary controls, they actually give us access to some of the background stuff so we can really narrow down what we're trying to look for. So, our first information here is starting and ending network number. So, every BACnet network has a number. By default, most systems set an IP level network to network number 1 or number 0. Excuse me. After that, if you have things like an MSTP network that's sitting off to the side of the IP network, or an old legacy Ethernet network, those will have a different network number. So on the back table behind Lanny, Sean, and Russell, there are some VAV controllers that are using MSTP. We have a router that's connecting our IP network to that MSTP network. That MSTP network's number is 201. Okay? I know that because I'm the one who set it up. If you don't know that, you've got to scan a whole lot of networks. Okay? The 65,000, that's 64K options. Okay? So that's how many networks you can have on a single BACnet system. If I ever run into a system that had that many, no. But it's possible. Okay? So if we wanted, we could limit our search. We could start with network 1 because that's our IP network, and we could stop at network 201. It would limit the amount of time required to do our scan. That's something that some companies will give you access to, but not all. What most companies do give you access to on their discovery tool is starting device ID and ending device ID. Okay? So if you have gone through and you've commissioned a network, you've set up the BACnet device IDs on all of your devices manually. Maybe you have 200 devices and your IDs run from 1,000 to 1,200. You can limit that range so it's only trying to look for devices with those ID numbers. Okay? Which is useful if you know the device ID of every device on your network. Okay? So for something like this network that everything has been manually configured, small network, easy to do. Large networks or networks where your device IDs aren't yours to set. Maybe they're based on serial numbers for your controllers. Or networks that have a third-party device. Maybe that classic train air handler. Do we know what its device ID is? Maybe we do, maybe we don't. If we don't, is it going to be wise to try and limit our scan? No, you gotta aim as wide as you can to be able to catch it. Make sense? Kind of figured it would. Now we're going to sit around now that I've talked too long and wait for my scan to finish. How many people's scans have finished by now? Yeah, I'm the holdup. Yep, that seems about right.
You can plug into the wall and scan your building here.
We could, but because all of our building automation systems are set off on a separate VLAN, we wouldn't be able to see anything. Definitely a good thought,
Robert knows how to get it.
and that's something fun to do in other buildings.
So I can't see
Or-
that because I'm scanning from it again,
Correct.
right? Okay.
Yeah, your specific BAS view will not show up on the list because that is the device that is scanning. But you are probably going to see everybody else's.
Yeah, no, I'm seeing you.
So is that the client?
Correct. Yes, your machine that you're scanning from is the client. Russell.
If all the devices are not showing up, like I got 21 items, you have to scan, can you do a rescan?
You can. So, Russell asked, can we do a rescan? If you think there's something else out there that didn't show up, absolutely. What you have to do is you have to close your scan, which is the X in the upper right-hand corner. Good timing, controller. The X in the upper right-hand corner, and then you just come over, right-click, and initiate a new scan. Okay? And sometimes that does have effect. Mario.
How would you know if you need to rescan? So my computer said 20 and 29.
So most of the time, if you're scanning a network, you're going to have an idea of how many devices should be there. So there are, what, 21 controllers, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 21, 22 of the contemporary controls. So that should, by default, you should run into 21 of those because you're not going to show yourself. There are 6 air handlers there on the back table, and there are 6 VAV boxes. So we can add all of that up. So 21 plus 12, 33 is the maximum you should find. Okay? Now, I'll be honest, the VAVs have not been playing nice, so they may not show up and play ball at all. So if you should have something around 27. 29?
29.
So that means VAV1 and VAV3 showed up. Those have been the ones that have consistently wanted to talk. So, Ramiro.
Why is it that the VAVA1 has the 201 semicolon 1 instead of an IP address?
So, great. Let me slide down to that one on mine. So, who had a VAV controller show up? Okay. You will notice on its address, instead of having an IP address like the air handlers do and all the contemporary controllers do, these have a different format of address. 201, and for this one, :1. So, Brad?
The network address and then the physical address of the controller?
Correct. So, 201 is that network address for that MSTP network that we were talking about a moment ago. And the :1 is its address on that network. Okay? And since it is an MSTP network, we are looking at a very simple single number address, somewhere between 0 and 255. Okay? Most of the time it's going to be between 0 and 127. But that's why that address looks very different. And it's one thing that should stand out on most discovery tools. Some discovery tools will put the address of your router here as well. Some do, some don't. Really kind of depends. Now, how many people in here have used a BACnet discovery tool before? Show of hands. Niagara, Johnson, ALC, EasyIO. How similar is this to what theirs looks like?
Very simple.
Pretty similar. You click the button and tell it to scan and wait for it to give you results. That is pretty much how these work. It's pretty easy. That's one of the nice things about BACnet. Okay? Or how we have chosen to implement BACnet discovery tools. There we go. Because it's not inherent to BACnet. It's just how we're using, kind of standardize that function. So again, that transferable skills. Okay? You teach somebody how to do BACnet discovery on one system. Yeah, exactly where the button is to click go and how to get there, that's going to be different for another system. But once you get going on it, pretty easy. Okay? So again, back to that Post-it note on your table. You will notice that there is an air handler number and a VAV number. Those are the two controllers I would like you to add if possible. If your VAV number is not there, just grab one of the ones that showed up. Okay? And to add them, it's really easy. So I need air handler 1. So I'm going to click over here on air handler 1. I also need VAV 1. You can see how they're both highlighted. Next up, plus sign in the upper edge. Right up here at the top. Add.
Oh, we go to air handlers. We would still go to
And you can see your added controllers will show up in your navigation tree here on the left, and they will disappear from this list. So go ahead and grab whatever VAV showed up on your scan. Yep, yep. Okay. So, everybody get a couple controllers added? Okay. So once you get them highlighted, hit the plus sign in the upper menu. Okay. Now, on this system, once you've added a controller, it disappears from your discovery list. Okay? That is not true for all systems. Some systems, this list will look exactly the same. On some systems, they will gray out controllers that you've already added to kind of show, yeah, we found them again, but we already knew about them. Okay? It really, that's very dependent on the implementation by the company. Okay?
So what you want us to do if one our VAV or HU's on there?
If your VAV or air handler isn't on there, well, if your air handler isn't there, you should scan again, because I know all the air handlers have been showing up. I mean, that was before everybody walked into the room, and we all know how that goes. But if your VAV isn't, just grab one of the VAVs that did show up for it.
You can find them easily by, if you click on name, it will sort them by name in the list once. And then once you start adding things, it doesn't seem to want to sort them again.
No, I already added, so it's pissed at me. So.
Why after you add it, sort, but
Yeah, how it goes. And like I said, if you've got to scan again, go up to the right-hand side and close out the scan, and then you can right-click and scan for devices again. Okay?
will it find the devices we've already added in the next game?
That's,
Find out.
so yes, it will find them again, but contemporary controls won't tell you that it found them again.
It won't show up in
Correct, it won't show up in the list again. I think they've chosen to do that because it was an easier way to prevent you from adding a device twice. Which, I've worked with some systems that will let you do that, and yeah, don't. That's my best advice there, is don't add a device twice. All right, but let's go ahead and click on our air handler over in the navigation tree. And you can see right now we have nothing under our air handler. Okay? Well, When in doubt, right click. So if we right click once we're in our air handler, we can scan for points. Okay. And again, this is a very standard thing to do in all BACnet discovery tools. It's sending that who has command to, or question to the controller. And it's going to go through and look and see, hey, how many points do you have? What do you want to talk about? What kind of points? What are their names? What are their values? All those kind of things. Okay? And you should find something like 257 or so points on the air handler control.
Proprietary object?
What's that?
Proprietary object scan or the quick scan?
Just hit scan.
Just hit scan?
Yep. So there are options on that one. Some give you options, some don't give you options. This one will give you the ability to look for just the regular high-level BACnet stuff or dig deeper for, weird stuff. Okay? With the air handler controllers, like I said, you should catch about 257 points. The first one is going to be the air handler's name itself. After that, you're going to get 128 analog values and 128 binary values. This is one of my pet peeves with the EasyIO controllers, is even if you haven't used an analog value or set it up, it still pukes it out onto the network. I think it's lazy programming. Okay? And the guy who wrote that part of it, I've talked to him, and he's like, yeah, you're right, it was lazy. Okay? What's that?
That is.
Yeah. So, we have, I think I set up about 10 analog values that we have that are doing things for us. So again, just like when we added the controllers, find the points you want, click on them, and then hit the plus sign. And it just brings them on over. Okay. Once you get your analog values done, scroll down a ways. I got some binary values down there too.
Just the ones that have a function.
What's that?
Just the ones that have a function like that.
That is correct. Well, you can add the others if you want. They're just not going to do anything interesting.
How about these like schedule ones and stuff?
Did yours show up with some schedules?
Yeah.
Like, you can spend 99 or
Oh, you got the newer versions. Newer firmware supported more device options. Don't worry about the schedules. Now, this is going to be something that is heavily flavored by my experience in the field. Many companies don't actually use anything close to all of the BACnet objects. Okay? They're going to be, especially if it's a fully programmable system like EasyIO or Johnson or, I just said the same thing, sorry, Schneider, ALC. If it has full programming options, most of the time it's not going to use schedule objects, trend objects, or a whole stack of the more advanced BACnet objects. Not exclusively, but a lot of the times. Most of the time, if you're going to run into things like BACnet schedules and trends, those are going to be things out of your factory-controlled air handlers. Rooftop units, chillers, stuff like that. Where it has its own proprietary controller that you can't touch. Okay? Then you run into some of the more, maybe exotic would be a better word to use, BACnet objects. But honestly, even then, we don't necessarily use them a lot.
That's an easy thing to fix, all right?
Ted?
There's one point on the scan in terms of agent mine sports.
Yep.
What's it, is that one we want to add in?
No, that is literally just the name or the object point within the controller that contains data about the controller. So it will tell you like the controller's name, manufacturer. Sometimes it'll tell you a firmware number for the controller, stuff like that. Can be useful, but at this juncture in time, unless your system has something like tagging associated with it, most of the time it's not. So, great question. I'm glad you asked. Okay. But when we get done, we should have somewhere a little less than 20 points. Okay. By the way, if you need to or want to expand your navigation tree, you have to close out your active scans and come up right up here at the top. There we go. Kind of in the space between the hamburger stack menu icon there and the actual line, and then you can drag out your navigation if you need to. Okay. This is one of those items that I would chalk up to this being a young product offering. You know, everything isn't super polished yet. They're working on it, and I think this really is a fantastic interface. But everything has room for growth.
Is this going to be upgradable? Will we be able to upgrade? Do you think, from online, upgrading the BAS group?
Yes. So, fortunately, the contemporary control. Oh, by the way, I don't know if you've noticed on the schedule, but we actually have a gentleman coming from Contemporary Controls who's going to come talk to us tomorrow. Joe.
Where's Lisa?
Yeah. So, I will. I'm one of those kind of people. When I get a new toy, the first thing I do is I take it apart. Okay, so really easy to take apart. There are about 4 or 6 screws you got to take out, and you can see what's in the guts. And again, don't tell Contemporary Controls I said this. I'm a little disappointed. I'm really happy about what's in here. It's just their price that they put on top of it, I'm less happy about. How many people are familiar with Raspberry Pi?
Is it really?
Yep. So that's somewhere between a $35 and a $50 computer, single board computer. They're really a lot of fun. That's what's in here.
I was going to say, we could probably do the same thing with a Raspberry Pi. I guess I was.
Yep, you were right on. So when Robin asks, do I think this is going to be upgradable later? Are we going to be able to update firmware? Is there more customization coming? As long as Contemporary Controls wants to work on it, there will be capability there. Okay. For those more detail-oriented, it is specifically a Raspberry Pi 3 that they're using inside here, which, again, not at all surprising. It's the same controller they're using in their BAS Pis and a couple of other devices, I think, as well.
Zach was working on this. He was one building like this.
Yeah.
He just had a Pi out in his lab, testing it out. So.
Where is Zach still there, or did he? He's where?
That's at Siemens.
He's at Siemens. Gotcha. Lanny?
So just out of curiosity, what you are saying is that we cannot open these, we cannot pull the code off of these, and we cannot open them onto our other Raspberry Pis.
That is, I am not saying that. You are 100% correct. So, now, again, from a technology standpoint, that, depending on what they've done, that could be really easy. Or they could have made it a little bit hard on us. That I don't know.
Do they have an SD card?
I haven't looked. It's a Raspberry Pi 3, and it's just the regular one. It's not the compute module, so it has to have a card. So it may be as simple as Lanny suggested we not do of just copying the card and loading it onto other Raspberry Pi. They may have set something up within their code so that it is specifically looking for serial number or MAC address of something on the Pi itself to deal with exactly somebody doing that.
Again,
So.
I'd say I do not have 30 Raspberry Pis sitting around, not doing anything.
Yeah, I don't have a Raspberry Pi 3 sitting on my desk waiting for this workshop to be over so I can risk breaking one of mine.
You will not have to let us know if you did not
So.
try that.
Steve, I think you... So, and I will not report back on my test results. Okay, so that being said, the reason I'm disappointed that it's just a Raspberry Pi inside is because you're taking a, you know, literally hardware-wise, $50, $100, and you're adding a zero to it price-wise. Okay, that's a little high for my taste. I'm not saying that this software development wasn't expensive. Somebody and multiple people put a lot of time in developing this software, and I 100% agree they deserve to get paid. I 100% agree that Contemporary Controls deserves to make money on this device. I think it is a fantastic device, and I really want to continue supporting it. Okay? I also think that with just a little bit further development, and if they chopped that price down a couple $100, they would slaughter the market, because it would get to the point where it's so easy and so cheap to use this for a medium or small commercial building. Why would you use anything else? I mean, realistically, that I would love to see them do that. If they're going to or not, I don't know. I don't know if that's their goal with this. For all I know, their goal may literally be targeting us for helping us teach students. They have been very supportive of us in the past and have committed to do so in the future. So,
When I first met George, it was a sizzle on the steak.
Mm.
Graphics. It took him years to get over that, get through it. Now he got into it.
yep.
And this is the product of what they came up with. How do you argue with the Pi though? You know,
You can't.
there's nobody that can touch that process and beat that economical period.
Nope. And I wasn't planning on talking about this segue, but one of the dysfunctions in the building controls industry is where they're living technology-wise. Okay? If you look at where building controls is right now, we are 10 years behind IT. Okay? So it's actually really easy to predict what building controls is going to do next year. You look at what IT did 9 years ago, that's our roadmap. Okay? It also, one of the other things that really frustrates me is the controls companies, and there's reasons behind it, but they don't update the hardware. When they design a controller, they design that controller. They design it for one chip or one series of chips, and they don't update it after that. Okay? So the Johnson Controls VAV controller that you bought 10 years ago within this model number is going to have the exact same chip that you would buy in that controller today. Okay? Well, look at the technology change in 10 years. You know, what was our processing power? What was your phone like 10 years ago? Okay? Versus what it is now, capability-wise. It's a whole different mass. Okay? And I'm not picking on Johnson because they're not the only one. Every one of the big control companies does it. That was one of the reasons why I was so impressed with EasyIO for so many years, because they kept updating the bloody hardware. When new hardware came out, when there was a cheaper chip that had more power, they're like, well, why wouldn't we use that? and gave it to us. Okay? For a short time, some other companies started to kind of start updating their hardware. And then they realized, well, we've given them access to too much power. If they want that much power, they've got to pay an additional licensing fee. Come on, I paid for the hardware. Get out with your licensing fees. Sorry. Now we're getting into opinions, but
You're not bitter at all about JCI buying ECI, are you?
not even remotely. Actually,
Okay.
I don't blame JCI for that at all. I think it was a very wise move on JCI's part. I definitely want to go talk to Gordon at the end of the stick. Gordon was the guy who owned EZIO. So, he is the one I have issues with. But anyway, I'm sure there were enough zeros on that check to make me understand. So, anyway. But that is one of the challenges with the controls industry. And when you've got a product that's going to live inside a building for 20 years, you do need consistency with it. So there are reasons, like I said. But, Peter.
So Robert, you're saying that when they do their major software updates,
Mm-hmm.
they're running it on the same chip they were using previously?
Typically, yes. So a great example is the Niagara 4 system by Tritium, owned by Honeywell. The Jace 8000 series has been out for 8 years? 9 years? No, it's more than 6, because we were on the beta sites, and that wasn't long after I started working here 10 years ago. So, but anyway,
Since 2012,
I would believe 2012. So somewhere around 9-10 years ago, the Jace 8000 came out. It is still using the same main chip. It is still using the same RAM. It is a stagnant device. And quite frankly, this Raspberry Pi 3, which is not the newest generation of Raspberry Pi, has more processing power in it than the Jace 8000, which most companies sell for somewhere north of $1,000 with very minimal licensing. You want big licensing on it, you can go up to 10, 12 Gs on one Jace. So yeah, we are not replacing these controllers every 2 or 3 years like we do with our computers. Anyway, Robert.
Do you think this right to repair will help? We should maybe jump on that a little bit? Or is that too far removed? Because it seems like it's related.
I think you're right. I think right to repair is related. I think right to repair is amazingly important. And unfortunately, I think our industry isn't going to give a shit. Because when you have as few technicians working in the field as we do, we're not going to repair things, we're going to replace things. As we gain technicians, that might change, but honestly, I kind of doubt it. And until building controls starts to push more in that open source direction, which is a huge component of right to repair on a software side, it will be, I don't want to say unattainable, but impractical.
Years and years, 0 to 10 volt signal, 420, and we're looking at a resistance. We don't need processing power.
Nope. No, you're absolutely right.
It's just a waste of money.
Yep.
Raspberry Pi is a good deal.
Yep. And again,
And their interconnection stuff with their other Raspberry Pi stuff that clips in.
yes, yeah. For those of you who aren't familiar with Raspberry Pi or Arduino, take a look at it. What Bob is talking about is what are referred to as hats for Raspberry Pi or shields for Arduino. And they're literally just stack-on, add-on modules. There's programming in the background that you have to do it, yes. It's not necessarily easy, it's not necessarily super intuitive, but it's also not really that hard. So,
For students, I mean, when I took a bike, when you look at it, the student price was like $75, $85 or so. I mean, you can have your own controller and go home and program stuff, you know, it's pretty cool for a student.
that is. That
Who else
really is.
doing that besides charging you $12,000 million?
Nobody.
And you're gonna pay me a licensing fee every year,
Mm-hmm.
you know?
And Contemporary Controls, their BAS Pies.
How much do auto students pay for Snap-on to come into their labs and get in debt for the next 10 years? You know, it's
You're absolutely right.
not your life away, kid.
So, again, like I said, I really like what Contemporary Controls is doing. I am going to continue supporting them to the best of my ability. I would encourage you to do so as well. Now, that being said, I still think Lanny has a great idea, because to be able to send this home with your students, that'd be pretty cool.
No, correction, I do not have a great
Right, well, right. Lanny does not have a great idea. Connie.
Well, I was just going to say, as far as using these in class,
Mm-hmm.
you can have multiple students use one.
Yes,
Build out.
absolutely.
Yeah. So it's not like you need one per student.
No, actually, I would.
It was intended to have one.
Huh?
It was intended to have just one.
If
For your whole
well,
network, just the front end of all the points together.
yeah,
Right.
but if you want to have multiple students practicing the graphics and the trending and everything, they
Mm-hmm.
can have multiple students per.
Absolutely. Yeah, when Bob started playing with mine, he was literally logged into mine.
Yeah.
You can do that with the BAS Control 22 controllers as well. You can have multiple students logged in working on stuff together on two separate computers.
Cool if they had an emulator thing where they could just upload it too.
Yeah. So I'm going to jump to Contemporary Controls website while we're on this topic. And I'm going to the page for the BAS View 3. And I'm just going to kind of scroll down and point out here on the left, BAS View 3 Demo. This is a website that Contemporary Controls is supporting that you can go to and log into a demo version of this controller. Boy, doesn't that sound like a great way to be able to tell your students, go home, go to this website, link it off of your Canvas or Blackboard or whatever you're using for that. Just link them there and say, go practice doing this task, because that's what we're going to do in the lab tomorrow. And if you're not prepared, you're carrying buckets around. Right? Okay? So that is a tool. I don't think that was Contemporary Controls' intention with that at all, but that's something that they've created public access to, so why not?
Whenever we ask, they always use it.
They do. They're really great with that. Okay? So, all right. Enough of me waffling on unless there are any further questions.
I've never played with it before.
I've ran through it a little bit. They've got backnet devices or virtual backnet devices or something connected to it, so you can really go through, you can create graphics. It's not going to save anything. The second you log out, whatever you did is gone. But for practice, I think it would be great. Or for those, I know, like Robin was talking yesterday, that for the last couple of months he's been thinking about getting some of these and was excited to get some hands-on time with it. But, you know, if you've got a colleague at another college near you or a friend somewhere who isn't sure about this and wants to play with it, throw them to the website. Get them to log in on the demo. Is it perfect? Probably not. But it beats paying $1,000 for something you realize, oh, I can't use this. This is garbage. Not saying that it is, but it's not going to be the perfect fit for everyone. All right. Sorry. Again, I waffled along for a little bit too long there. But we have all of our points. These are all living underneath our air handler 1 controller. Okay, so we have access to them. We can click on like our, let me go discharge air temperature. Okay, my current discharge air temperature just went up to 58 degrees. Okay, I can override this if it is a writable point. Okay, I can manually set it to something. I can also see the little lock next to my up and down arrows. This is our priority array. Okay, something that's built into BACnet is a stack of 16 different priorities. Okay, this is something that is very standard in almost all control systems, whether they're using BACnet or using something else, is this idea of a priority array. And it's just the idea that a higher priority takes precedence. Okay? So if right now my value is coming in on priority 1, okay, there is nothing higher than priority 1. I cannot override this point. Okay? But if it were coming in down at a more normal priority, priority 8 or priority 10 are common ones, then I could write something in any of these priorities above here, and it would overwrite that value. Okay? That can be useful for testing purposes. That can be useful for operator overrides, things like that. Okay? 16 is our lowest priority. It is commonly used for things like schedules. Okay? Priority 10 is a normal operating priority. So most of the time, if you have something like a reset schedule controlled set point, so let's say we've got a discharge air temperature that's reset between 55 and 65, most of the time you would bring that in on priority 10. Okay? Because then priority 8, which is your operator override level, and it's a standard level, that's where we let our operators change things. So if you want an operator to be able to override it, you have to write it initially at below level 8. Okay? If you don't want the operator to be able to override it, you need to be somewhere above priority 8. So maybe we're going to write it at 7. Okay? Administrator or emergency overrides happen at priority 2. Priority 1 is reserved for life safety. Okay? You should, as a rule of thumb, you should almost never be doing something on priority 1 that isn't related to something like a fire alarm. Make sense? Rob?
When you bring this up in from your discharge air temperature, those are those all your priority? I'm having a little trouble. So the priority is a flag that's associated with this object, or is it a list associated with the whole with the AHU?
It is a list associated with that point.
So whenever we bring up this list from whatever point, it's always going to look the same. That's going to be that 59 point, whatever it is.
It's actually going to refresh that list because that is our value. So if I bring it back up, right now it changed to 49 point something. Okay? Because this is the value, these are the values that are being set to that object. So if as our discharge air temperature changes, the values shown here will change.
Okay, so this priority is associated with that point.
Correct. Yes.
Okay.
It is built into the BACnet object. And it is present in most of the data point, like measurement type or outputs or things like that. It is built into all of those types of BACnet points.
So this is a read-only value,
Not necessarily.
Discharge air tank.
It should be a read-only value. I got around that by setting it priority 1 so you couldn't overwrite it.
I was wondering if that was the case, whether read-onlys were set at priority 1.
No. Writable and read-only are flags that can be set on each backnet point. But that's going to be set at the server end on the controller that has that data.
So it's a tag that's related to the device on the controller, not a flag that's on the device, that lives on the device, and goes to all, anything related.
No, the tag is associated with that data point. So when I create the discharge air data point in that controller as a backnet point, I have the ability to make it read-only or writable.
Okay, I think I'll catch up.
Okay. Some backnet points by default are read-only, like that air handler 4 name that Ted asked about earlier. That is by default, or that is a read-only point. There is nothing that we can write in that because it's literally data tied with that specific controller. Ted?
So when you set up these different points on here, was there automatically a default priority set up to that particular item once you set it up? Because of the
On the BAS view side?
yeah, well, right.
No. These priorities all exist. So it is reading from my air handler back there. It is checking the value at priority 1, 2, 3,
Okay, so it
4.
pulled it in.
Correct. This is literally pulled data on this.
Client conversation.
What's that?
Maybe it's the client conversation here where it isn't clicking
Could be.
with the server, because you gotta realize that you're setting priority so that you don't want some idiot operator changing something on a controller from the front end. That's what you're isolating here.
All right.
And you can only change it and you can override it. If you go into the controllers, you can override it, put your own variables in and everything else. But give me that ability. This is just a way of a supervisory level, not letting all the people that don't have a clue about chill water set points, make sure it's not a freezer, right? Blow up your chiller, right? The chiller killers. This is what it's all about right here. Stop.
Yeah. So we cannot change the priority here. It's just the priorities of the controller.
Correct. Yeah.
We can lock it.
I don't know what that button does. Hang on.
Your administrators can go in and do it.
Oh, okay.
Yeah.
And then it doesn't go back,
Well,
or you just redo it.
there. As soon as you can hit that lock button and it will wipe out whatever value is there and replace it with null.
Okay.
But if on the controller side, if something rewrites that value after you've set it at null, it's going to go back to whatever the controller wrote it as.
I would think you would call this the server.
Yeah, because
You would.
I know, but that's why I was making.
Yep.
It just,
Yep.
this is the controller that looks at everything and manages it all.
supervisor can have.
This doesn't have points on
Right.
it. There's no points on this.
Yeah.
It's all a network.
Yeah. This is just a virtual representation of the point that's in that controller at the back.
But you
It is
tie all your
giving
stuff
us a window into that controller, if you will.
together.
Okay. So,
Where's Larry? Larry, talk about architecture.
so as you can
Watching
see,
YouTube right now.
we've got a whole stack of different points here. I literally made them up. There is nothing physically tied to those controllers, as you can see. I just literally have some ramps and some math running in the background to play with the values and make them move around and dance for you. Okay, that's all that's going on here. There is, from the controller programming side, if you want to see it, I can show you sometime, but
It's running on an
It's not.
emulator of some sort?
no, it's running on that controller. I'm just throwing garbage values into it. It's nothing real. Okay. Now, one of the things that I forgot to add to these controllers that would be a useful thing, something that is going to be very common in most building controllers, and something we're going to need later, is an occupancy point. Okay? Now, your chiller doesn't care about occupancy, your boiler doesn't care about occupancy, but your VAV boxes, your air handlers, they better care about occupancy, right? So, we're going to create a virtual point inside this air handler, and that point will actually live in the BAS view. Okay? And it's really easy. They made it easy. So right here below all my other values, I'm going to right click and create a new item. First option on the list is create, or new point. So I'm just going to make a new point. I'm going to call it OC. And down here where it says address, I'm just going to leave that blank. And right below that, there's a checkbox that says virtual point. Okay? I'm going to click that. And that's what's going to tell the BAS view, hey, there's no address that we're going to go read data from. There's no address we're going to go write data from in the controller. This is just a point for us to work with. Okay? Now, because it is an occupancy point, I'm going to come down here. I'm going to change from an analog to a digital value. Okay? I'm changing to a digital value because it's easy for us to work with later. Occupancy points in controllers, sometimes it will be a digital value on and off. Sometimes it's going to be this multi-state value down here where we have many options. Maybe we've got unoccupied and occupied standby and emergency occupied and nighttime occupied, or morning warm up, or the list of options with multi-states is really as far as you want to program. Binary is easy, or digital is easy. So I'm just going to select digital. I'm going to change it from an input class to a variable. Okay? For those of you who have mice to scroll with, your life is far easier than those of us trying to scroll with the bloody touchpad. So feel sorry for us. Next thing I'm going to come down, I'm going to hit this display settings. Okay? And this is where our value, we can set up what our values mean for the data point. Okay? So we'll hit the select button, and we have a whole list of things that we can go through. So if we scroll down through this list about 1,000,000 miles, we will eventually find occupied and unoccupied. Nope, there we go. Oc, unoc.
There's two.
Okay? Now, I do want to point something out that's really important with this. Our values. 0 is occupied, 1 is unoccupied. Does that make sense? Intuitively, no, it doesn't. You would expect if it's going to be occupied, we need to turn it on, right? Okay? That's one of those things. It's a great discussion to have with your students. Okay? Up in Wisconsin, in Chicago, when we're dealing with boilers, do we turn them on or do we turn them off? Depends on the time of year. Fair enough. In winter, do you turn the boiler on or do you turn the boiler off? You actively choose to disable it. So if your control system dies in the middle of winter, that boiler is going to turn on by default. Okay? It is defaulting to a safe state. Okay? That's something we have to think about with controls all the time. Who in here has dealt... so I know this isn't going to apply to Ramiro down in Palm Spring or Palm Desert. It's probably not going to apply to our friends from Texas either. But for those of us in the more northerly climates, what happens if you lose power to an outside air damper? Okay. It depends. What does it depend on, Bob?
Depends on where it stops.
Depends on where it stopped.
Is it open? Is there a crowbar in there?
The facility guy?
Assuming no further outside influence, if we lose power to the outside air damper, what should happen?
Yeah. And I shut down.
It should close. Spring return close.
It's part
It's
of what type of damper control you got on it. You got a spring return or you don't have spring.
fair enough. And largely that's going to depend on what the device is and where in the country you are. You know, Ramiro, we've had this discussion before when I've been down at his college. They don't use spring return actuators on their outside air dampers because it's safe. They don't run into freezing temperatures at all frequently. Up in Chicago, Green Bay, Madison, you know, Michigan, Sean, you use spring return actuators on your outside air dampers because if it fails in the wintertime, you want that sucker to go closed so you don't break stuff. Okay? So, our occupied point is the same way. We want to fail to a safe state. Landon.
So, but they give you the choice of choosing a different occupied and unoccupied.
Yeah.
Yeah, if you go further down, yes. And you can manually change these here as well. You can literally type in and swap them if you want to. Okay? You could manually set this up so that this binary value chooses between dogs and cats. Control system doesn't care. It's a digital value. It's going to really read it as a 0 or a 1. But for our interpretation, when we start displaying it on graphics, these, a lot of different programming languages call them facets, and it's just kind of those display characteristics. This is important. From a programming background standpoint, computer doesn't care. This is totally operator clarity. Okay? I'm going to leave this as dogs and cats. That way when we get to schedules tomorrow, I'll be confused as anything and you can laugh at it. Okay? And now, once I'm done, I have this occupied point over here that again is just a virtual point. It's just software sitting inside the controller. We would have to do something with it to make it useful. But it's there. It's ready for us for later. Okay? And there are oftentimes requirements for us to have a number of these virtual points ready for our controllers. Okay? Occupied is not a standard one. It's literally, I forgot to program one into the controller for our schedule exercise later. Okay? But other things that would be useful might be software-based alarms. Okay? We need to do a little bit of math and have a placeholder for it to build an alarm off of. Or maybe we want to look at the error between our discharge air temperature and its set point, and we want to log that error. Okay? So we've got to do some math, and then we've got to stick it in a point before we can log that data. Those are the kind of things that we very frequently use virtual points for. Okay? And when you are programming a controller, you use a huge number of virtual points. All of your set points, or almost all of your set points, are virtual points, if it helps you think about it, because they are not typically tied to an input or an output. So everything that's not tied to those really is a virtual point. Okay? It's just a matter of where it's living. If it's living in the controller, it's the controller's virtual point. If it's living in your supervisor, it's your supervisor's virtual point. Okay? Make sense? Questions? Steve?
So
So let's say you grab the wrong one.
Okay.
You get rid of it.
Okay.
So you just right click on it.
Yep.
Can you just delete it?
You can delete it and recreate it, or you can right click on it and edit the point. And then we can come back in, and if I decide, oops, I didn't have those display settings right, or I chose a digital value and it should have been a multi-state value, come in and edit it. Fix it how you need it. Okay? And I should clarify, if we were to look at like our discharge air temperature, I'm going to come in and I'm going to edit this one as well. So this is a point that is in the controller. We can see it's at address analog value 11, AV7. I'm sorry, I said 11. Should have said 7. Okay. I was. Okay. But I'm going to scroll down here. You know, I'm not going to change my point type or anything like that. But if I come in here to my display settings, right now, I don't have any engineering units set. Okay? What's our standard unit for air temperature? Right? Degrees Fahrenheit. That's right. Oh, it's going to be real funny when we do calculations. If we scroll down, we can find degrees Fahrenheit. Okay? Ta-da! Now, when we display this, it will have a Fahrenheit temperature. So if we click on this now, we can see before it just said a number here. Now it has a unit. Okay? Very frequently, that unit is actually going to be selected at the controller. I got lazy with my programming and forgot to set units. Okay? But if your controller isn't providing you units, you can adjust it. Okay. Great question. What if it's giving us Celsius and we want to convert to Fahrenheit? Well, it's giving us Fahrenheit. Let's convert to Celsius. How about that? So again, I'm going to right click on it. Hey, go away. There we go. And I think edit point. And if we scroll down further here, past display settings, I think it's under modification settings. Nope. Sorry. Advanced. Here we go. Under advanced, we can select calculations. So if we wanted to convert from Fahrenheit to Celsius, that's our in calculation, Fahrenheit to Celsius.
What would that be used for? What would that be?
You will run into systems.
If you get like feet per minute, you want to do like CFM. Okay.
Exactly. You know, there are, you can take measurements and convert them to be more useful for you directly on a display purpose. I've run into boilers that only gave me Celsius for the temperatures, and having to convert it to Fahrenheit, you know, when it's built into the point, that's useful. Now, one thing you do have to be careful with, if you do use this feature, you're going to need to change your units, yes, but honestly, what's more important than that, if it's something that can be overridden, you need to change your out calculation as well. Because if we're changing this to display in Celsius, if we write in a number in Celsius, it needs to convert it back to Fahrenheit when it writes it to the controller. So if you're converting it one way and it can be overwritten, you need to convert it back. Because if your building operator is
explain that in a set point, not just an input.
True enough. Yeah. That would be a better place to do it. So right here, our discharge air temperature set point. We'll change this one. And again, it's just down in advanced. We'll change it to Fahrenheit, or to Celsius. What should I just do? Yeah. There we go. Okay? So right now my discharge air temperature set point is 13 degrees Celsius. Okay? But the controller is measuring in Fahrenheit. So if I were to send in a new set point in Celsius, maybe I want it to be 10 degrees Celsius, that controller is going to say 10 degrees? We can do 10 degrees Fahrenheit, open that chilled water valve. Okay? Right? So we have to convert it back. So be careful anytime you use these built-in conversions. If you convert it one way, you need to convert it back the other. So we went from Fahrenheit to Celsius for our display purposes to match whatever the user wants. And now when we're sending it back to the controller, we're going to flop it the other way. We're going to go from Celsius to Fahrenheit.
You're selecting these conversions. Can you write your own?
Absolutely, yes. To Sean's point of taking a air velocity and converting it to a CFM, that would be a great example of writing your own. You'll have to be a little bit careful with the syntax. You notice this @ symbol here? That is our value that the point is getting. So that's our X value, if you will. Okay? So you always have to include that. And trying to do more appreciable functions, you're going to want to go to the help to see what the math, the syntax would be. So if we need to do square root, is it SQRT? Is it SQ? What is it? And this would be a great time to point out help. On almost every window we've been on, there's been this little question mark in the corner. If we open that up, that will go to the help menu that is directly related to that item. Okay? So if we needed to know what our syntax was for calculations, hopefully it will tell us here. Not super excited with what it gives us, as far as I was hoping for a list of options for things. But we're going to deal with calculations outside of points here in a little bit, so we may be able to get that then. This does bring up another point, another reason why this can be very, very useful. BACnet, when it is set up, is usually pretty good. When we say on a temperature, if we say 72, we mean 72. Modbus, that isn't necessarily the case. They may say 7.2 and expect you to multiply that value by 10. Or 1.7. Or whatever that manufacturer decided to do to optimize what they're doing. Or, honestly, I think some of them just do it to screw with us. But, hey, that's my perspective. Okay? And, as we said before, these controllers are capable of talking to Modbus devices. Okay? Modbus is still a widely used protocol. As we've discussed before, it is not as friendly to work with as BACnet. You know how we discovered our controllers? Modbus doesn't have that functionality. You have to know the addresses of the controllers and manually add them. You have to go in and manually add every point in Modbus. You have to understand how Modbus registries work, which is a topic. We'll leave it at that. Okay? But this help is here. And the help files, honestly, I think the help files are better than the user manual they have so far, because it is far more detailed. Okay? We good on points for now? Or what questions do you have, I should ask? It would be a better way to phrase it. Okay. So, 9:30. I think we're going to hit just a little bit of PowerPoint before we can take a break. Is that okay? So, now that we have points in our controllers, what can we do with points? We've got data. Let's do something with it. Data just sitting off alone in a corner isn't useful, is it? I mean, don't get me wrong, there are plenty of professions that collect data for the sake of collecting data. Wasn't going to say it. So, one of the most important functions of a supervisory controller or a head-end controller or a front-end system is alarms. Okay? How many people have done anything for or seen building operators in their building? Wandering around, looking at stuff, checking numbers. Okay? I'm not saying that isn't important because it definitely is. But depending on the size of your building, you may only have 1 or 2 operators, and if you've got a 30-story high-rise, are they going to be able to check everything every day? No.
How many are going to understand what they're seeing?
We don't want to talk about that. You're absolutely right. That's a fantastic question. How many of them can properly interpret the data they collect? That's a whole separate topic. Okay? But back in the days when all of our systems were pneumatic controls, you had to have somebody wandering around checking the building. Okay? Their job was to know when the building was broken or a system within the building was broken. Okay? With modern building automation systems, your building should tell you when it's broken. Okay? That's what alarms are. They are, hey, I'm broken, or hey, I'm about to break, or hey, just so you know, this is going on.
Well, grew up with Homer Simpson.
Well, what?
Grew up with Homer Simpson. Silence the alarm.
Yeah. Yep. And it used to be, because that brings in the next point, how were alarms delivered? Okay? And in some situations, Homer's control room at the nuclear plant, the alarm starts going off, there's a button that says, shut up. Okay? And it used to be that in every building, we would have an operator's workstation. And we would send all the alarms to the operator's workstation, and there was probably a console that just had a list of the alarms. And part of the operator's job every day was to come in and look at the list of alarms and start addressing them, hopefully. Some of them were just recorded. Ah, this went into alarm again, sort of thing. Okay? Sometimes we also would have a printer attached to that workstation or attached to that system. And when you got an alarm, it would automatically print off the information about that alarm. Maybe it was formatted in such a manner as a work order, or sometimes maybe it was the chilled water pump 2 is broke, dummy messaging. Okay? So that's how we used to do it. Honestly, in some buildings, that's still how we do it. See referencing of control systems lasting 20 plus years. 20 plus year old system probably still does it that way. Okay? And there are reasons why sometimes we do that. If you have a person at Homer's desk 24/7, then they can act as a dispatcher saying, hey, Charlie, go check pump 2. We got something wrong. But in modern buildings, most of the time, unless they are required to by code, most companies don't want to pay the money to have somebody sitting there staring at a screen all day, especially when that is an expensive position, which most of the time it is. Okay? So, nowadays, we send messages. Email is one of the most useful ways or common ways that we send alarms. Okay? And when I say we send emails, I don't mean we just send emails, because email is one thing, sure. But we can also email to text. So you can text your on-call phone saying that this thing is in alarm. Okay? Oh, one of the ways we also used to do it, and sometimes still do, is you would have an old-fashioned dialer attached to part of your system, and if an alarm came in, it would actually call the on-call phone. Some places still do that, though that's trying to find the dialers to do that is getting a little bit more challenging. But there are software ways to accomplish the same thing. Okay? Remember that comment about, hey, this went into alarm again? Nuisance alarms. Okay? When nuisance alarms happen for a reason. Okay? Maybe things aren't set up properly for the alarm, or maybe we have a periodic problem that just shows up and, oh, it's an issue, oh, it's not an issue. Okay? Sometimes it's an alarm that was specified when the building was created that really isn't useful to the operators. Okay? Now I got a question. Are nuisance alarms bad? Ooh, I like that, Mike. So, Mike said it creates a habit of ignoring alarms and automatically resetting. I would argue nuisance alarms are really a bad thing. The boy who cried wolf. If you're used to your control system saying, hey, help me, I'm broke, and it's not, then you're going to tend to pay less attention to it when it actually is, and you may cause problems for that. Okay? Develops bad habits. There are some people that theorize here in the U.S. that the days of prohibition can be followed through to our current habits with speed limits and speeding. That prohibition created that concept of the scoff law, the person who isn't going to pay attention to the law because it's really stupid. And you can follow that trend through to modern speeding habits. I don't know if I entirely buy that, but it's kind of a fun story. Okay? Russell, you said that, you were nodding your head that nuisance alarms are bad, or shaking your head.
Or what type of nuisance alarms they are.
Depends on what kind of nuisance alarms they are. You're absolutely right. It could be a valid alarm that's just slightly improperly set up. Absolutely. We'll run into those on a regular basis. I think the next slide... not the next slide. The slide after that is going to address some questions related to that. Okay. Most systems have the ability to set different priorities to alarms. Okay. Not all systems. Most. Commonly, we're going to have alarms. Everybody has alarms. These are things that need attention now. Okay. This is the chilled water pump failed. This is the boiler failed. The air handler fan failed. Okay, this is stuff we need to fix. Okay, we need to go and investigate it as soon as possible. Okay, there are still priorities within that list. You know, you get 10 alarms that show up at once. You got to prioritize what you're going to deal with, of course, but you know that all these things need to be dealt with. Okay. You may also get warnings, okay? Things like a room temperature out of range, okay? Maybe it's up to 75, 76 degrees in this room, okay? Is it a problem? Yes. Well, maybe. Hopefully it is. If we're getting it as a warning, it's a problem. But is it something we have to go deal with right now? Maybe not. Okay? Maybe we can let it float for half an hour while we deal with something that did fail. And we can come back to it and reevaluate. And get the result of another alarm. Yep. And oftentimes, warnings will escalate into alarms. So maybe it's 76 degrees in here now, that's a warning. If it crosses that 80-degree border, maybe that triggers an alarm. Okay? Also, messages. Okay? Believe it or not, your building control system telling you general things that are going on can be a really helpful thing. Maybe your system will send you a message going into morning warm-up in the morning when that triggers, because you've got an optimized start-stop, so it's not always happening at the same time. But you can kind of track when it's doing and how it's doing. Or maybe it's going to send you a message, hey, it's been a month since you changed the filters. Maybe you should go take a look at those. Okay, things along those lines. Okay, but they aren't problem-oriented. They're just a statement of, this is happening, you should be aware of. Okay? Messages, I think, are one of the things that are commonly very underutilized within big control systems. Okay? Make sense? Depending on what your control system is, like I said, you may only have one priority, and everything comes in as an alarm. And you've got to deal with how you deal with it past that. Other systems will be limited to 2 or 3 priorities. Some systems have huge arrays of priorities. I dealt with one older system that had 64 different priorities for alarms. Like, okay, that gives me all the versatility I could never want. Talk about overkill. Okay.
Some BFDs have alarms and then they have faults.
Yep, alarms versus fault. That's a great comparison. So, questions to ask when creating alarms. And this is a great discussion to have with students. First thing you should always ask about an alarm, is this actually useful? Is it needed? Okay? This is maybe something that you, as an installer, can't answer without talking to somebody else, talking to the building owner or building operator. Hey, is this something that's going to be useful to you, or is it going to be annoying? Okay, back to that conversation on nuisance alarms. Okay. If it is useful, what exactly are the trigger conditions? Okay, what is going to cause this to go into alarm? Exactly. Okay, remember, computers are exceptionally intelligent, stupid devices. They are only going to do what you tell it to do. Okay, so if we were to tell our system that we need to alarm when our room temperature is at 75 degrees. Okay? What's going to happen if it's 75.01 degrees? It's not going to go into alarm because it's looking for that exactly 75. This is one of those things that can cause a nuisance alarm, something that's improperly set up. When in reality, we wanted it to say anytime it's 75 degrees or above. Okay? And sometimes we can set hard limits like that. If our hot water temperature rises above 185 degrees, we want to create an alarm because this is a water system, not a steam system. We get above there, we need to start looking at things. Okay? Other times, we are going to need to compare two things. Room temperature versus room set point is a great thing to compare, so that we look at the set point in relation to the room temperature before we create that alarm. Because before we said 75 degrees and above, we want an alarm. What if the set point's set at 76 in this room? Do we want to have an alarm?
Like we just came out of unoccupied mode.
What if we just came out of unoccupied? What if, well, we're going to get to that
The equipment had
possibility.
to catch up.
I mean, I would kind of argue that maybe we need to set an alarm for that to come slap whoever changed the set point that high, but
Also, what if you got a range between 70 and 75, and you got that alarm set at 72?
yep,
You're still within that range, whether the unit may be off or not.
absolutely right. If we're existing within a deadband range, we better not have an alarm that exists in that same range, right? We need to take those kind of things into account. Okay? And there are other things that are just an on-off value that create an alarm. Okay? Fire alarms, low-limit thermostat trips, things like that, things that happen. Okay? Hey, it was just everything's normal, everything's fine. Uh-oh, trouble. There are transitions like that. We still use a lot of those kind of things in the systems. We try and usually program around or avoidance tactics for tripping those types of alarms, but we don't always succeed. They're there for a reason. They're safeties. Okay? Sometimes we also have to look at two different digital points. We commanded the pump on. Status says it's not on. Well, I'm going to assume the pump's broken. I got to go look at it. Or, on the converse side, something that we don't always think about, but we need to, especially from an energy standpoint. Hey, I told the pump to turn off. Status says the pump is still on. Somebody put it in hand. Somebody turned it on to manual mode because they needed it to run for a maintenance purpose or something, whatever, and forgot to turn it back to auto. Happens. Also, that could be a sign that we have a bad status signal. Somewhere we've got a shorted wire, bad status donut, list of possibilities. But it's something that should be investigated. Okay? All that tracking. Another thing you need to ask about alarms is time. Okay? To Mike's point, this room just came out of unoccupied mode and it's the middle of the summer. Our unoccupied set point in here is 80 degrees. Well, if our set point is 70 degrees and we've got a 10-degree alarm deadband, well, 80 degrees is an alarm. Okay? But does it need to be an alarm? Right now, we just transitioned. Or should we give it 10 minutes or 20 minutes before we make that alarm active and go piss somebody off? Okay? Again, prioritizing the operator's time. Okay? With things like, let's come back up to statuses, fan commands. On big air handlers, we always have variable frequency drives anymore, right? Well, sometimes we are still using a current donut to monitor status, okay? Sometimes we're letting the VFD tell us, yes, the fan's on. Sometimes we're using an electrical device. Well, those electrical devices have to be tuned, and if it takes, 60 seconds for your fan to ramp up, and that status donut doesn't turn on for 45 seconds, we turned it on, status isn't on, status isn't on, status isn't on. If we set that alarm right away, if we don't have that delay, then we end up with that nuisance alarm. And back to Russell's point of alarms that aren't set up properly. Okay? alarms seem like a pretty straightforward thing, right? You know, in concept, when something's wrong, you set an alarm. Pretty easy, right? They're much deeper than that. There's a lot of thought that should go into creating alarms. Okay? Once the alarm goes off, we've got to deal with the other side. When should it resolve? When should we admit, hey, the alarm condition has passed? Okay? And in many situations, it's just the opposite of what triggered the alarm to begin with. Our temperature was out of range, we came back into range. Okay? Whether the issue was resolved by a technician or resolved by time, the alarm, whatever it is, it's not a priority anymore. Do we still need to look into it? If somebody didn't, maybe, maybe not. But that thing that's currently screaming for help takes priority. Okay? And sometimes alarm conditions or clear conditions aren't the same. And we have to acknowledge that and set up accordingly. Peter.
Robert, in the real world, you get a BAS guy out there in the field. He's programming alarms.
Yep.
He has not a real solid grasp on the way mechanical systems are working in the building. How quickly can this go sideways? and who's checking his work?
So that is a fantastic question, Peter. So when we build a new building, if we have a technician who isn't familiar with mechanical systems in general or those specific mechanical systems, they can make mistakes, especially when setting up alarms. Because, hey, they've got a sheet of paper from the engineer that says you're going to make this alarm and this alarm and this alarm and this alarm and this alarm. Okay? Maybe one of those alarms isn't actually useful to the building because it doesn't apply to this piece of equipment really. Instead of a fixed discharge air set point, it's a variable set point. So trying to alarm off of that may be challenging. And it may miss a whole stack of alarms because this piece of equipment got added later on and didn't catch that part of the spec for update. Okay? That is, finding those types of things is part of the responsibility of the technician who initially installs the building. And I would also argue that it's part of the job of the building operator and a service technician to work together to find those. But in short, to directly answer your question, Peter, how quickly can it go sideways? At the speed of a keyboard. Okay? Plain and simple. And I'll fully acknowledge I screwed up a bunch of alarms when I first started because I didn't know mechanical systems well. But I learned. I learned from my mistakes. Okay? And to finish addressing your question, who is checking on these kind of things? Depends on the building, depends on the area you're in, depends on the companies you're working for. Sometimes it's nobody until something goes wrong and people living in that building have to deal with it. Sometimes it's a commissioning agent who comes along afterwards to commission the building and check out all of these things like alarms. Sometimes it's going to be the engineer who comes through and investigates everything after the building is done. That was something that we did in Wyoming a lot, but honestly, I never saw it happen here in Nebraska. I never went through a system from beginning to end with the engineer who designed it once it was done. But that was something that we did with almost every system that I did in Wyoming. I don't know if that was a code requirement or just how the engineers in Wyoming worked. I don't know. But sometimes it will be going through it with the building operator or the building owner or their representative.
Maybe something builds
expensive breaks and then to get to investigating why didn't they fix this?
Boy, that is the truth. When something expensive breaks, then somebody's really going to look at it. Something cheap breaks, once it's the fifth time, well, then maybe somebody will start, why does this keep breaking?
Well, the operator doesn't know what they don't know. They don't
True.
know that an alarm was set up incorrectly.
You're absolutely right.
And it seems like, I mean, we're not presuming that the programmer really has a deep knowledge of building systems. They have a good knowledge, a working knowledge, or should.
Yep.
I mean, it seems like we designed it to fail. Whether the failure is catastrophic or a minor nuisance.
Yep. You're right. We
Unless
we
it's-
have kind of set things up.
Unless it's
Where-
commissioned and well executed, and how often is that?
Yeah.
This goes to my statement or my question that I actually asked you yesterday, that I asked Peter, is we have these high-performance buildings, but we don't have qualified people to operate and service them.
Correct.
And the push for our industry is to build these high-performance buildings to eliminate our carbon footprint. What are we going to do about educating the people that we currently have and people coming into this trade to service them? To your point, in California, you have the new construction and you have the retrofit industry.
Mm-hmm.
And I am familiar with both and work in both circles. There is no checks and balances. Somebody comes in, oh, we're gonna put this control system in and sell you a bill of goods, and that bill of goods falls real short of what they actually are
What they
supposed
actually
to be
need.
selling.
Yep.
And then you've got, in my side of it, I see alarms that are disabled,
Mm-hmm.
schedules that are non-existent, buildings running 24/7.
Yep.
Because they can't, on a hot day, they can't cool the building down. So we're gonna turn it on and run it 24/7.
Yep.
Instead of it actually addressing the issue.
Yep.
It's things like that that I see on the service side that just really frustrates me.
Oh, absolutely. I 100% agree. And it is indicative of our current industry. It is, I think, the result of a time period where we have not done a good job of training people, and also indicative of our current lack of workforce. Because in the controls industry, it's get in and get out. You know, on new construction type projects, you did not, I didn't have time to do things like properly tuned PID loops. It was throw initial values at it, make sure it's not going to blow anything up, get out. Okay? It's, you're going to check calibration on sensors for air handlers, maybe spot check a couple of VAV boxes, pass that, get it done, get out.
I like the service side of it when you go to replace the static pressure transducer and you
And
don't
find
buy
out-
like for like, and then all of a sudden you can't open the doors in the building.
Mhm.
I'm sitting there.
Yep.
Ain't good controls.
Yep. So that's,
Because your range is no longer correct.
yep. And it's largely indicative of we've got so much work and so few people.
I know.
Kind of towards the strategy that Peter talked about yesterday, where some companies are going to a B team, A team approach. B team does 90% of the work, and A team solves 90% of the problems. And that whole concept just sits so horribly with me that it is not funny. I'm not saying that it doesn't get done. I'm not saying that it doesn't happen very regularly, but
Trying to mechanical guys were telling me that they were doing something like that, that had their 20-year lead techs sit on the phone and
Yep.
they had 6 guys working under them that were out in the field doing the work. They did something they called it.
Yep. You put your most, one of those things, you put your most senior tech into a support or leadership role instead of out in the field doing the stuff that they probably actually prefer to do and they're really good at. And unfortunately, in many situations, we also do not provide those technicians with the support to succeed in that position. So,
They were wearing cameras on their hard hats.
mhm.
So he could sit there and watch what they were doing.
Yep. I've heard that from Train as well. And to Train's credit, I think their program is actually succeeding better than a lot of others because they are using technology to support this idea, making it practical. Rob.
It seems like it might be one of the things that we want to talk about on Friday. What could we do? What could happen? What changes could happen in the industry to move it? We've seen other industries move ahead of this. We're saying we're 10 years behind. We're 10 years behind. What's going to help us get the year ahead? Because we can't catch up. We have to jump forward. How to do that? I mean, we have codes for how buildings are built. We need codes for how buildings are run. Do we need to really, temporary controls as a leader in AI applications and control it? Your PID loop, you should not be tuning PID loops. There should be some sort of AI that does that
Self-tuning.
on a continual basis and
Yep.
find something that we never could find because we're limited to thinking about the model that we have.
Yeah.
I think we've got some real opportunities, not for us necessarily,
But for
the world.
Yep. And I think you nailed that question very, very well right at the beginning of instead of trying to look to figure out what we need to do to catch up, we need to figure out what to do to be ahead. Because if we're trying to catch up to today, we're always going to be trying to play catch up instead of working ahead.
Building movement's all about?
Lead building.
They don't consider energy, so they're just lead.
I like that. I really like that. I'm not a fan of that group either, personally. But
But they have
Anyway.
maintenance and operations.
yeah,
What was the best practice? But
yeah.
they don't have the green stuff that make the buildings don't work right, because they don't understand it.
And especially with lead, it's very largely a numbers game. You do things to gain points, like only having 4 stools in the men's bathroom in a building that's going to support 400 people at a time. Not that I've lived with that problem. Anyway, back to alarms before I get off topic in bad area. Okay, we have to figure out when alarms are going to go back to normal. Okay, we also need to figure out who needs to know about alarms. Okay, how are the notifications getting sent? And do we have the infrastructure in place to make sure those alarms get where they need to? Are we constantly texting the manager's phone and making him or her dispatch those alarms? Are we sending it to a central workstation that everybody checks in with every half hour to get their to-do list of what they got to go fix? Are we texting alarms to the on-duty phone? Okay, those types of things. Is the email client properly set up on our supervisor so that it actually sends the alarms? Brad laughs because he's lived that one. Okay, but there's a lot that goes into alarms. Okay, and this also comes back to those priorities. Are we telling the manager about every alarm? Or are we just telling the on-duty phone about every alarm? Are we notifying the manager about alarms at all? Does the manager care about the alarms, or is it just annoying? I've got people to deal with this. Why do I keep hearing about it? Okay? Because if the manager's job isn't to deal with dispatching and making sure those alarms get dealt with, then every alarm to them is a nuisance alarm because they've got bigger fish to fry. So because of the slide style that I picked, everything in the title bar is caps lock. But when I was typing this, I had my caps lock on as well. Always test your alarms. Drive this into the students' heads. Stomp it into them. Always test your alarms. Okay? As far as I'm concerned, a building tech or automation system technician, part of their responsibility is to test everything in their system. Okay? If I'm telling a fan to turn on, it better turn on. If I'm telling it to turn off, it better turn off. Okay? Now, this is from a perspective when a building operator is not involved. This is when you are checking out to make sure your control system is operational before you turn it over to somebody else. Okay? When you're testing alarms, does the trigger condition initiate the alarm? That's the first part of the test. Okay? When an alarm is initiated, does a notification get sent properly? Does it land where it needs to land? When you're creating new buildings, this can be a particularly challenging one to do sometimes because they may not know exactly where those alarms need to end up yet. Okay? But you test to the best of your ability in that situation. When the alarm clears, when the conditions are met, the alarm should clear. Does it clear? Okay? Do we send a clear message to wherever we sent that alarm to? Sometimes we do, sometimes we don't. You know, warnings, messages, most of the time we're not going to follow those up with a clear. But especially if you're sending an alarm to multiple recipients, you want to notify them that, hey, that emergency alarm that came in 10 minutes ago, it's cleared, somebody's dealt with it, or it's dealt with itself. Okay? And that's one thing that I did forget to add to things you should talk about with alarms, is the messaging associated when you send an alarm. The messaging that goes with an alarm needs to be useful. If all of your alarms say, alarm, come on, don't be that lazy. Give it a useful message. Air handler 1, supply fan failure. Okay? Or you can't use room temperature out of range. Okay? That's great. What room temperature? I have 800 rooms in this building. Which room is out of range?
When will the fire?
Fire it. Those types of things. Okay? Those need to happen. They need to be useful messages. Okay? And that, sometimes that is an onerous task. Depending on your control system, sometimes you have to go in and manually set up every stinking alarm. Okay? Also consider when you're doing those messages, is there a temperature reading or an associated data point that is useful to include in the data for that alarm? Room temperature out of range, room 117 at 82 degrees. Okay? Am I dealing with over range or under range? Those types of questions. Okay? Some systems are developed so that you can reference as part of the message, like we had that @ symbol for our calculation. We can use tags within most alarms to create additional information. So we can say, have a general out-of-range alarm that we can kind of copy and paste down the road. And we just reference, is it the room temperature? Is it the discharge air temperature? What is the parent object of that temperature? So is it room 112 or is it room 114? Those type of things. Most modern systems have that ability. Is it simple to learn? Is it simple to set up? Not until you get used to it. Once you get used to it, then it becomes much easier. Those initial growing pains can be challenging. Okay? Last point on this slide. Anybody ever heard of a fair witness before? Anybody much into sci-fi? Heinlein? Heinlein created the idea of a fair witness in the novel Stranger in a Strange Land. Okay? The idea behind a fair witness is they are a person whose profession it is to observe and report events. Okay? And they observe and report what they see. If they didn't see it happen, it didn't happen. Okay? I adopted that perspective when I was doing controls. Back to my statement of, if I tell the fan to turn on, it better turn on. If I tell it to turn off, it better turn off. If I didn't see it happen, I don't trust that it happened. Okay? If you do that, if you get your students in that kind of a mindset and habit, they will succeed very well. Because hopefully, after they're done as a technician at a building, somebody's going to come along afterwards and check their work, a commissioning agent, an engineer, hopefully. Okay? If you've gone through and done your work, if you have proven to yourself that it works, they are going to have very little to find, very little to fault you on, and it's going to be good. You're going to get a good reputation for being somebody who is reliable and consistent. Now, I'm not going to say they're never going to find anything. Everybody makes mistakes, right? But if you limit those, if you prove, if you test it, you will limit those mistakes. And you will find your own mistakes before somebody else does. Okay? Not saying mistakes are bad. Not saying somebody else finding your mistakes is bad. But the more you limit that, the better, or the more likely you are to succeed in the industry that we live in. And other people have taken the fair witness concept and applied it to other things as well. Questions on alarms? I guess in a nutshell, one of the things we can say, alarms, going to be a lot of work. It is not a simple topic. Implementation of alarms, not so hard. We'll find that out here shortly, but background behind it requires a lot more thought. Take a break.